In 3.4, we learn the chain rule. And we just devote the entire section to this one rule that we're going to learn and then put into practice. So the chain rule, what's that all about? It feels different than the previous rules. So, we had the power rule, we've got the rule, product rule, quotient rule, we've got the rules for all the trig functions, their derivatives, e, right? Constant multiple. Uh, those all, to me at least, they have a similar feel. The chain rule has a different feel. Why is that? Because we're going to be looking at the derivative of any composite function. And if you recall, a composite function is something of the form f of g of x. Okay. So, it's kind of not your typical operation. It's not addition or subtraction, or it's, a composite function. Okay. Let's look at a couple of examples of composite functions, then we'll see the rule, then we'll go for it. So how about this? And kind of ignore what I wrote here for a moment. Y equals x to the third plus 1 quantity to the fifth. And thinking about that, you might say to yourself, you know what? We actually don't need any new rule for that derivative. We could multiply this out 5 times. And we could, combine like terms and it'd just be a big, long polynomial. Well, that's true, but we really want a much faster way to take the derivative of something like x to the third plus 1 to the fifth. And, the fifth, that would be a pain to multiply out, but, what if it was to the 50th power or something? Like, yeah, okay, we definitely want a faster approach, and we're going to get it with the chain rule. Notice how I labeled the different parts. So the part that's inside the parentheses, we literally think of as the inside function. And maybe I can write that too. That's the inside function. And what's on the outside, we think of as the outside function. And here, that's just a fifth power. Okay, so that's going to come in handy later, just setting us up. Let's look at another example. Now this one, there would be no alternative. There's no multiplying or simplifying this. F of x equals the cosine of the quantity x to the fourth plus x squared plus 2. And in this case, we're going to think the composite function has an inside and an outside. There's our inside function. It's literally inside the parentheses. And on the outside is cosine. If you think back, just to a composite function, we think of the g. G of x is the inside. The f is the outside. And we can identify that, in these examples. Okay. So let's see the rule. Here it is. I'll just show you all of this. Let's talk through it. The chain rule. If you want to know the derivative of a composite function, f of g of x, here's how it works. You take the derivative of the f. So f prime, but we still leave g of x inside of it. Okay. Then we multiply that, and now here's where we do the derivative of the g. Gets multiplied on the end. And so what's a handy way to remember the chain rule is once you identify the inside and the outside, what you do is you take the derivative of the outside, so that's the f prime, and you multiply that by the derivative of the inside. And these are like, the name comes from, these are like two links in a chain. Like link 1, link 2, okay. One thing you gotta, that takes some practice to get used to this rule is the fact that when you do f prime, for this step at the beginning, you leave the g alone. That goes untouched. All you do is copy it. let me show you what we mean. Let's go for it. Find the derivative, and we'll start with that first example. Y equals x to the third plus 1 to the fifth. Okay, so we pointed out before, we can see the inside function, and the outside is the fifth power. So I didn't write this one all the way out because it's really helpful to kind of think through it. So I've set it up though, and we'll fill this in. Okay, so y prime. What do I have here? We start with the outside. So the outside is that 5. So what does a derivative of a fifth power look like? Well, that's just a power rule. So the 5 would come down to the front, and the new power, the new exponent, would be 4. So there the 5 moved down, became a 4. This is f prime. That's the derivative of a fifth power. Okay? And then just kind of remembering that in this first step, all we do is copy the inside. What goes in here? So I thought it was handy to leave it blank so we can really focus on that moving, but we're also going to then just copy that inside function. So the 5 moves down, becomes a 4, but this goes untouched for the moment. We just copy it. Okay. Then we're going to multiply, and now comes the second link in the chain where we take the derivative of the inside. So now we focus on that inside function, and we get its derivative. Well, derivative of x to the third plus 1 is 3x squared, and that's it right there. Move the 5 down in front, drops to a 4, copy the inside, then take the derivative of the inside multiplied onto the end. If this was a test and all I wanted was for you to find the derivative, I would also put don't simplify, so you could answer right here. That's the unsimplified version, a test or a quiz. But here it's really not bad, right? 3x squared we could multiply with the 5, and there's our simplified version. And we got it. Okay. Let's look at that other first example with cosine. And so I've just copied that one here, along with labeling the outside and the inside. Okay, when you use the chain rule, when I teach this course, there's a lot of the same comments come up, and questions and comments that come up, while we're in the midst of lecturing when it's a live lecture, right? One of which is students usually immediately identify, okay, if what's inside the parentheses is the inside function. Okay, that's it. If you're seeing that, already, that's awesome. There's one exception, but and we're going to look at that exception in a moment too, of course. But the vast majority of these, it is literally inside parentheses. Exactly. And then, what's the outside is whatever is literally outside the parentheses. Okay. When you start the rule, we always begin on the outside, and then we work our way inside. Okay, so here we go. And we'll kind of fill this in. So if you remember, f prime x equals, the derivative of cosine is negative sine. So I'm going to think, okay, cosine derivative is negative sine. And what happens in here? We're just going to copy. Don't be tempted to do both derivatives in the same step. It doesn't work that way. That's not the rule. Okay. We do the outside only. The inside goes untouched. Then we put our focus on the inside, and we take its derivative here multiplied. Now in this case, there's more than one term. that's going to come out of this. So I need a set of parentheses because it's got to be a quantity. And my derivative 4x to the third plus 2x. And that will be multiplied on the end. Okay, there it is. Really not much to simplify there. I mean, what else could you do? Not a whole lot. Think of the chain rule. A good analogy is think of it like layers of an onion. So you peel back the layers of the onion. You start with the outside, you peel that off, right? Then you move to the next layer inside. So we start with the outside, but we haven't touched the inside yet, right? We just peel this layer, and then we move to the next layer, right? And there are these links in a chain. Okay. Hey, we got more. You know we got more. Just a whole bunch of examples, really. Are these sections. Once we lay out what the rule is, then all right, let's do a million examples of various styles. Okay, here we have y equals e to the x over x squared plus 1, all raised to the third power. All right, so first thing you want to do is identify the inside and identify the outside. The inside, of course, here is everything that is inside the parentheses, all of that. And the outside is the third power. Okay. So we'll begin with the outside. Y prime is going to equal, begin with the outside, the 3 will come down, it'll be dropped to a square, all right. And inside the parentheses, we don't touch it yet, it's still e to the x over x squared plus 1. Then we move on, and we go to the derivative of the inside, and you think, oh, how are we going to take the derivative of that inside? We're going to need quotient rule. So inside this chain rule, to take the derivative of inside, we need the quotient rule. All right. Well, okay, I know how to do that. So quotient rule here. If you remember the limerick, low d high minus high d low, all over low squared, and away we go. So here comes low. The derivative of high, of course, is just e to the x. Low d high minus high d low, all over the low squared. There's your quotient rule. Hey, at least you get to practice those old rules as we learn new rules, right? Oh, man. Okay, at this point, we have the derivative outside, derivative inside. If this was a test, you could stop right here and say, that's your derivative. Calculus done. But hey, for the practice, why not simplify? This will actually simplify pretty darn well. Let's try it out. I think I need a paperweight here. Okay. So, simplifying. Here's what we can do. I'm going to keep this first part the same. Here, since they both have e to the x, I'm going to factor e to the x out. And it's going to leave us with x squared minus 2x plus 1, if we put those terms in order. Okay. Next step, I'm going to go ahead and apply this square to top and bottom. So e to the x squared, if you recall, we're going to multiply those exponents, so it's going to be e to the 2x. And that denominator will be x squared plus 1 squared. Now that's going to be nice because it's going to combine really well with our other denominator. Okay, so we got the 3 e to the 2x over x plus 1, x squared plus 1 squared. And over here, it just so happens, as just kind of a nice coincidence, that polynomial factors as x minus 1 squared. So here, you know, this is kind of, in this situation, it's just kind of a happy coincidence that it factors, and it's really even personal preference to factor it at all. We could leave it as x squared minus 2x plus 1. Nothing wrong with that. I mean, nothing's going to cancel, right? Okay, we're almost there. Here's our fully simplified version. What just happened? So if we multiply these fractions, e to the 2x times e to the x, we would add exponents, e to the 3x, and we've got that x minus 1 quantity squared, and the denominator happens to be x squared plus 1 to the 4th, and then we can put that 3 up in the numerator as well. So that's a nice fully simplified version, looking pretty good. Okay, we've got more examples to come in the next video.